Tech by Tips.
Hello and welcome to another Tech by Tips video. In today's video we're going to be addressing a comment that was added to a video that I uploaded about 1 or 2 weeks ago, and this request comes from KBP Trin, and this person says, "Friggin' lifesaver, thank you so much. LoRA training next please with 5000 series with Kohya. Instant subscribe. I'm starting my journey with a 5080 and just got into this. Got sent after 10 hours of incompatibilities." So this person found the video regarding setting up Kohya with 5000 series useful, and he wants to learn, or she wants to learn, how to create LoRAs now that they have a 5000 series card and Kohya installed. So we're gonna get to that on this video. So let's quickly mention that if you like the content, hit the like button. Let me know if you want to see more of this type of content. This video is gonna be kind of a lightning guide on how to create a human character, like a human LoRA, so a realistic LoRA. So if you want me to go into details as to all the options that you have in Kohya in the user interface, so you can understand better what you can tweak in there, let me know, and then I can create a video regarding that. So this is going to be straightforward. Let's create good quality human character LoRAs. Alright, for this video I'm going to use a public personality, very famous. It's going to be President 47, also known as Donald J. Trump. So the first thing that we need to do when we are going to be creating a LoRA is we need to get good quality images to create a good data set. So that's the first thing that we need to do, and we need to understand a couple of things when it comes to that. Number one is what type of model we're going to be using to train the LoRA and to generate the images using that LoRA. For example, maybe you have older hardware and you don't have the VRAM necessary to use more recent models, like for example Stable Diffusion Extra Large or something like that, which is capable of generating larger images and usually uses larger images for training. So in that case you would probably go with Stable Diffusion 1.5, for example, which is the beginning models that are available, but they're very developed and very useful still. The only difference is that for those, then you would need to get images that are smaller, usually 512 by 512 pixels. So that's the first thing you need to understand. Which model you're going to be using, your hardware could be a restriction on that, and then depending on the model, what's the size of the target images that you need. So in my case, I'm going to be training using the Stable Diffusion Extra Large model, which is one of the newer ones. So this one by default is going to use images that are 1024 by 1024 pixels. So that's the minimum size that we want to have for the images to be useful for the model. So that's the first thing that I wanted to cover, right? The second thing that I wanted to cover when it comes to the model is you might benefit from using a model that might already have been exposed to the character or person that you're trying to train on. So for example, given that President Trump is a very known figure, it is very likely that Stable Diffusion Extra Large has already been kind of trained a little bit on images that contain Mr. Trump. So that would be an extra benefit that we get from using that model. Let's say you're going for a very specific character or something that is kind of niche or unique, then if you can find another model that has already been trained on that character, then it'll help you even more, because then your training doesn't really matter that much when it comes to the model having an understanding of that character. But if you don't, then you just make your data set even more important. So now let's go into the data set. For this video, I'm going to be dropping everything into a folder named video in one of my disks in my computer. And you need to have this folder structure. You need your dataset folder. This is where we're going to drop our images that we're going to be using. Then you also need an image folder, that is IMG. And then you need a log folder, that's LOG. And you need a model folder. What are these folders, right? So this is where we're going to be working on our data set, where we're going to be putting our images, where we are going to caption our images. Then in Kohya, we're going to tell it, okay, use the images that are here and then add some parameters to that. And then it's going to move all of that into the image folder here. And the naming of the folder is going to tell Kohya some important things about the training. Then log is where we're going to see all the log files that are related to our training. So if something goes wrong and you want to check, you can always come into the logs here and look for that training session and see what happened. And the model is where in the end we're going to see the final LoRA files that you have trained, and then you can grab them from here and use them in wherever you want to use them. So that's the folder structure. Now we're going to be working on the dataset folder first, so let's have this ready here. Now in my case, I said I'm going to be using Stable Diffusion Extra Large, so I need to look for big images. So in this case, for example, if I see this image in his Twitter, this is pretty small. So this image would not be good for me, even though it's pretty good when it comes to having details and all of that. But the size is too small, so I'm not going to use that. I need to find images that are kind of close to what I need for my model. So I'm going to go into the media files here. They have very good photographers in the White House. So I'm pretty sure I can find a couple of images here that are pretty nice. So this is small, so I'm not going to use this. Let's look for another one. All right, this is a big image, so we could, in theory, grab this image and use it. So let me save this into my directory. So here we go. I'm going to save this, and we're going to continue looking for images that are pretty good quality, pretty big, and we might be able to use. This one is also pretty big, so I might be able to work with this one. This is not good enough. There's too many people. That's another thing. You want to try to focus on the character. So this one, even though we kind of have people, they're blurred in the background, so this might be useful. It's pretty detailed, it's pretty big, so we might be able to use this one. So I'm going to store this one too. This is a pretty detailed image of his face, so I'm going to save this one. Even though we have some text here, I'm going to get rid of that later because it has a lot of details, and here I'm going to detail some important things when it comes to the dataset, at least from my experience, right? If you're going to be creating a character of a person that is going to be realistic, you need to have a good amount of images. I would say at minimum, you should have about 50 images. And out of those 50 images, I would suggest that you have about 10 minimum that are close-ups of the face. And if possible, it should be in different angles. For example, you can see Trump here looking forward. You can have another one where he's looking to the right, another one where he's looking to the left, another one that he might be looking kind of up or diagonally up, looking down. This is very important because the face of the character changes depending on the angle and the position and the different lighting. So you want to have variety, but with good quality and good details so that you can recreate this person, this character, without having to kind of come up with things to fill the things that the model doesn't learn from your images. Let me continue looking for other images, and then I'll just go over them after I have a decent enough size of images. Alright, so I have collected about 50 pictures here of President Donald Trump, and as you can see, there are different sizes, different dimensions, different positions. Some of them are close-ups of the face, some of them are like a full body. I tried to find some photos where he was dressed casually, but it's very hard. He's the president. Most of the photos you'll find out there are dressed in formal attire, but I did find a few that were not in formal attire. So the first thing I'm going to do is I'm going to rename all of the images something that is the same. So I'm going to name it Donald. I have different extensions, so that's another thing that we need to do. We need to make sure that all of the images that we have are of the same extension. So let's fix that before we try to rename. Alright, so I have all my images here, but they're not of the same type. So what I'm going to do is I'm going to use this program called XNConvert. It's a freeware, you can find it online. And I'm going to import all my images here, and I'm going to say that I want to output this as PNG files. And then I'm going to be able to run this, and this program should convert all my images into PNG. So let's click convert, and then it says the files exist, you want to overwrite them. So let me just make a change here, make it save it into another folder to make sure that I don't get any problems with that. So we go into the PNG folder, and then we're going to do it here. Alright, I was able to convert most of the images. There was one that gave me an error, and unfortunately I lost it because I had selected here to overwrite the files. So I need to get one more PNG image, but we should be good now to almost be ready to start. So let me just grab everything out of this folder and dump it back into the original folder and get rid of the PNG folder. There we go. And then let's look for one last image. Alright, I have 50 images now. They're all PNG, so I should be able now to rename to get a coherent order of names. So let's see if that worked. There we go. Now we have names that kind of follow the Donald and then the name, and we have 50 images, so that's pretty good. Now, one thing that I want to make sure is that I don't have images that are way too big, because I know for sure that I grabbed some images that are like huge. I want them to be kind of on the 1024 to 2000 pixels on the biggest size. So I'm gonna look at the images and see if any of them is too big. Then I'll just reduce the size of that so that it is not too big, because then that's gonna cause problems with the training. I want it to be kind of in the range where it's manageable for Stable Diffusion Extra Large. For example, if we look at this image, if we hover over it, it's gonna tell me details about it, and it says that it's 3840 by 1920. So that's way too big. So this is an image that I'm gonna bring down a little bit using a tool like GIMP. So as you can see, this image is huge. I'm down to 25%. So I'm gonna resize this lower. So I'm gonna get the image and I'm gonna say that I want to scale the image, and then I want to make it like 1600 on the biggest one of the sizes, and then I scale it, and then now it's a lot smaller, so it works better with Stable Diffusion Extra Large, and it still looks very crisp. We can see all the details of his face and everything, so everything is look good. So I'm gonna overwrite that image. I don't want you to watch paint dry. There's a few more images that are also pretty big, like this one. So I'm gonna keep on checking all the images and fixing any one that is too big to make it more manageable for the training. So here we go. I cropped some of the images to remove unnecessary people so that the focus is on Donald, and I made sure to reduce the size of some of the images but keep them like they were because they were good enough, and this is what we end up with. So this is good enough. We have a few nice face photos that have a lot of details. That's great. And like this one, but we also have like far out photos, full body, where we can see Trump in its entirety. So I think this would work okay. I probably shot myself in the foot by picking Trump because the photos are very similar. It's really hard to find variety of photos from him, but you know, if you're gonna make a LoRA of yourself or a family or something like that, it's very easy to take a bunch of photos with your iPhone or your Android, and they're going to be good quality, and then you're going to have a bunch of variety. So then in that case, you don't really have to worry much. So now that we have this, then we're ready to start working with the dataset, because the first thing that we need to do is we need to prepare this dataset. So for that, let's go into Kohya, and to make it easy to see everything in the video, I'm going to split the screen like this. So I have the Kohya interface on the right side, then my command prompt on the left with the folder with all this stuff. So now the first thing that we're going to be doing is we need to caption all of these images. So we fortunately have a tool for that in the Kohya application. So we can go where it says utilities down here, and then we have captioning. When we go into captioning, we have several options. You don't see it all here because the thing is small, but let me make it a little bigger. So we have the basic captioning, the blip captioning, blip 2, git, WD14, and manual. So the two ones that probably are used the most right now are the WD40 and the blip 2. There's a big difference between the two of them. WD40 uses the Boru type of captioning. So basically it puts keywords separated by commas in here. While the blip 2, which is kind of gaining fame and use now, relies on like entire sentences that describe what's going on in the image. So they can be very beneficial for different use cases. For example, if you want to be very, very detailed as to what you want to generate, then blip 2 probably is better because you can create full sentences describing the setting, the character, the clothing, any accessories, any objects that are in there, and the actions and all of that. So it gives you a lot of granularity when you're generating the images, but also you have to understand that it's going to work if your model is trained to behave like that. Before, most models were trained using the WD14, so it was basically keywords separated by commas. So that's more tricky when you're generating images, but it's pretty useful too if you don't really care that much about what it's going to do with the image, or if you know how to actually write the prompts using that. So I prefer to do the WD14. Most models currently do that, so I'm going to go with WD14. Let me bring this back up to where it was before, or close to that. And then in here we have to select several things. It says what's the image folder that you want to caption. So you click here, and then you need to look for that folder that contains the images that we are looking for. So in that case, in my pop-up, I'm going to select the folder that contains all my images, which is this one, video data in my F drive. So I select this folder, and now it's going to populate it here. And then I'm not going to touch any of this. Then it says, how do you want to store the captions? I'm going to leave it in the default as a text file. So there's going to be a text file with the same name as the image, and that's going to be good. We're going to use a comma as a separator, and then we're going to scroll down a little bit more. I'm not going to touch this part here. I never touched this, so ignore that part. On the sire tags, that's if you want to put things that you want to be sure that you remove from the automatic captioning. I almost never use this. And then on a prefix to add, this is very important, because in here you would put the keyword or the trigger word that is going to give you the character Donald Trump whenever you're generating an image. So for him, I'm going to say POTUS 47 is going to be my trigger word, and I'm going to put a comma here because that's the first thing that is going to be showing up in my image. So that's good enough for me. And basically I don't touch anything else when it comes to generating the captions. That's all I do. Make sure that it's a text file, make sure that I pick the right folder, and make sure that I provide a trigger word here. And now once I have that, I can click on caption images, and then you see it's going to read my folder, and then it's going to go ahead and kind of look at the images and kind of identify what it sees in there, and then it's going to create a text file for each image that it's going to have the words that describe what's in the image. And that's going to be what is being used when we're going to be training the LoRA, so that based on the information that the base model that we use knows, we can create a low rank adaptation that refers to this specific character that I'm trying to create in a way that that model can understand it. So let's just give it time, because it needs to read stuff, and in the beginning it kind of takes a little bit of time, but once it starts, it's really fast. There we go, boom. So there we go, and as you can see, it finished. Now we have files for every single image. So Donald 1, if we click here, we'll get the file that describes Donald 1, and if we open the image, we can then compare to see if it makes sense, right? So it says that we have POTUS 47. That is correct. That's the character that we have here. And it says it's him, so solo. He has a shirt. He has long sleeves. That's correct. He's a one boy, so it's only one person in the image. His mouth is closed. He's standing. He has a jacket. You can see the full body. His shirt is white. His hair is white. You can change that if you notice that there's some kind of difference. I'm going to leave it as that because it looks kind of whitish in this picture. He's a male. His focus is on the male. This is outdoors. The clothes are open, talking about probably the jacket here. He's wearing shoes. He has a collared shirt. He has a belt, pants, black footwear. There's a tree in the background. He's dressed formally with a suit. There's grass in the photo. He has a blue jacket. There's a vehicle in the background. There's a motor vehicle. So also the pants are blue. His shirt is tucked in. There's a car. he's old, he's an old man, and basically everything here makes sense, so we can assume that the captioning was good for this photo. But we need to do this for every single photo. We need to make sure that the captioning makes sense, that it is accurate, we don't have any weird stuff in there, and that our trigger word is in every single one of those files. So I'm not gonna again have you watch paint dry, but I'm gonna check on those before we continue. So let's pick another one. Just for example, this POTUS, he's alone, he's looking at the viewer with short hair, blue eyes, brown hair, kind of brownish looks like, so I'm gonna let it be. He has a shirt, long sleeves, he's alone, closed mouth, he's standing, he has a jacket, all that looks good, a necktie. I don't see anything here that doesn't look right. So again, we're good. We're going to continue with the rest of the images, and we'll be back when I'm done verifying all of that. Alright, I have checked the images and the text, and everything looks pretty decent, so I'm not going to make any more changes. Now we need to work with the continuation of this, which is we now have our data set, but we need to prepare the folders and everything for us to get ready to train. So in here in Kohya, we can go back into the LoRA section here, and then the first thing we want to do is we want to make sure that we get all the contents of this data set and we move it into the right place. So we have an option here that says dataset preparation. So we can go into here. Always make sure when you're going to work with LoRAs that you select LoRA on top, because by default it's going to start on Dream Booth, and I've had this happen to me several times, and then I start working and then I realize that I messed everything up because I was looking at the wrong thing. So make sure you're in the LoRA. So for dataset preparation, here's something very, very important. So the instance prompt is the same keyword that we use for the captioning. So in this case, I'm going to put POTUS 47. And then the class prompt is, what kind of LoRA is this? So this is a man. I'm creating a character of a man. So I'm going to say this is a man. And then where are my training images? Well, we need to look for this folder here. So we click on the folder, and then we can go into the right path here. So it's in the F drive video data set, and select that. Now it knows where my images are. Now this is something very important, the repeats. What does that mean? Well, it means when you're training, you have to look at the images, how many times you're going to use the same image to train. So that's why it's called repeats, because you're repeating the use of an image in the training. So if you have a lot of images, then your repeat can be very small because you have a lot of different data about the character that is going to give you plenty of good information, right? The smaller your data set size, the bigger you have to make your repeats. 50 photos is pretty decent, so I'm gonna say that I'm gonna give it like 20 repeats, and let's see how that works for us. And then regularization images, that's something that you can use to make sure that it doesn't overfit the training, but honestly for LoRAs it's seldomly used. I never used it honestly, so ignore it. And the repeats for the LoRAs, for the regularization images, also ignore it. And then what's the destination training directory where everything's going to be stored? So that's going to be this root here that has the image, the log, and the model directory. So we're going to look for that in here, and we're going to select that directory here. That is where we have all those folders. So I select that, and there we go. So this is going to do the following. This is going to grab those images that we have in the data sets, and it's going to dump it in here into the image folder, but it's going to name the folder very particularly, and it's going to get everything ready for us so that we can start the training. Now we can create on prepare the training data, and you see, boom, surprise, what do we have here? It created a folder inside the image, and if you notice, it has a very specific pattern, a number, and that number matches exactly the repeats. So this tells Kohya how many times to use each image in the training, and then underscore, and then our trigger word. So in my case it's POTUS 47, so that's the trigger word, and then space, the class. So in our class is a man, so man. So this is the format that you have to follow for this directory. Let's say you do the training and you are like, maybe I need to training a little bit more with each image. You can just come here and change the 20 for 25, for example. Or maybe you say, maybe I think I overtrained it. So then you can come here and lower that. Or maybe you're changing and now you're not going to train a man, you're going to train a woman. You can then change the trigger word and the class and then change the images inside it, and then it's going to be working fine for you. So that's the pattern that it creates in here. And if we go back, there's nothing in log yet, there's nothing in model yet, and dataset still has our original dataset. So that's the preparation. Now, there's another folder here that says copy the info to the respective fields. That's talking about here where it says folders. So you see there's nothing there. So if I click in that, now you see it populated that. So that's good. Now we're good. We can close this dataset preparation section. And this has been populated, so we're looking better here. We can close this section out. And one thing that I would recommend when you're working with creating a LoRA, always save your configuration, because you want to make sure that you don't miss anything, and if for some reason the application crashes, you don't lose it. So open the configuration, click on the save button, and then pick a location where you're going to store that configuration. So I'm going to store it in here, and I'm gonna name it POTUS 47. So I know that that's my configuration for POTUS 47, and I save that, and there we go, it saved it. So now whenever I click save, it's just gonna save directly into that file. So that's important right here. So now we're ready to start configuring the application to do the actual training. So in here, this is what I usually touch and has given me great results. So the first thing is the model. So we have to select the base model that we're going to be using to train. So by default, it's going to use Stable Diffusion 1.5 here, but you can always change this. It has a bunch of different options here. So see if you have what you need here. If you don't see it, then you just basically have to get it and then download it and put it somewhere that it is accessible. But in this case, I already have Stable Diffusion Extra Large Base 1, so that's what I'm going to be using for the training. So I select it, and again, immediately I save my configuration. Then this thing that says trained model output name is what the safe tensor file is going to be named as. So I'm going to name it POTUS 47 and then SDXL, because that lets me know that that's my trump LoRA for SDXL. Perfect for me. Save again. And now in here it says the image folder that contains the training images subfolders. So that's this folder. So the path is correct. We don't need to do anything here. And then dataset config file, we don't need this. And then we don't need to do anything else here. And here we select safe tensors as the extension of the file that we want to get for our model. And then in here, depending on your graphics card, you have to choose either FP16 or BF16. In my case, I have an RTX 5090, so I can easily go get the BF16. But if you have an older card or your VRAM is not a lot, then you should be safe going with the FP16. Even if you have the 5090, you can also go with the FP16. So I'm going to use that as a base and save that. And we're done with the model configuration here. Now the next thing that we have to do is on the metadata, there's really nothing that I ever do here. So I'm going to leave that alone, and we're going to go into the parameters. And this is the crucial part here for the training. We are going to select that this is a standard LoRA, and I'm going to go down here, and this is important too. The training batch is how many images do you want to use at the same time when you're training. So this depends a lot on the amount of VRAM that you have. If you have like 8 gigabytes, you probably should not put here more than 2. Even if it crashes with 2, then just bring it down to 1. If you have 16, you'll probably get away with somewhere like 6 or 8. But on the safe side, you could go with like 4 to 6. And if you have like 24 or more, then you'll be safe with going with a number that is all the way up to like 12. So in my case, Just for you to see how it is, I'm going to leave it at 1, but you can select based on the VRAM that you have. And then here it says epoch, and this refers to how many epochs you want to train in this session. So I prefer to do like about 15 epochs, and I'm gonna save the epochs every time it increases, and then I can just compare to see which one gives me the best result out of that. I'm not gonna say a max train epoch, I'm just gonna leave it as 0, but then I want to save an epoch file every 1 epoch, so I leave that as 1. And then max training steps, if you say this number, then it's gonna stop training at that amount, and your amount of epochs is kind of not going to get fulfilled. So I'm gonna switch this to 0, and then we're good with this first block here. Then on the second block, I'm gonna leave it at 0 because I want to leave that seed randomized, and you want to cache latents, and you want to cache them to the disk if possible, because then that also reduces the amount of VRAM that you use when you're training. So I always highlight that. And then here for the scheduler, I'm gonna go with the constant scheduler. The optimizer, I'm sorry, is gonna be the Atom W8-bit, because that's very optimized and it doesn't use a lot of VRAM and gives you pretty decent results. I'm not gonna pick any scheduler type, I'm gonna leave it like it is, and we're good in there. Then for the next section, I honestly don't touch it, don't do anything with it, so leave it alone. Now this is important, the learning rate. This basically tells the model how much information it should try to memorize on each step of the training. So you don't want this to be too big, because then it's like if you're studying for an exam and you're trying to memorize a bunch of stuff at the same time, it usually doesn't work out. You don't remember the things and then you make stuff up. So you want this number to be pretty small. I found that 0.0001, which is the default, is fine. So I'll leave it at that. I'm not going to touch the other options that we have here. I'm going to go down. I am not going to touch this section either, so I'm going to scroll down. This is very important. Like we said, we're training SDXL, so I want to increase these to 1024 by 1024, because that's the default size of the images for SDXL. So I'm going to make sure that I have that in there. Another thing that we want to highlight here is that check enable buckets. What does that do? Remember that I have a bunch of different images, but the images are not exactly the same size. So we have some images that are longer horizontally, others that are longer vertically, others that are about the same size in both directions. So the buckets allow the training to break down and kind of separate the images into buckets of images that are kind of similar in size. So you want it to be able to kind of train with images that are kind of similar. So enable the buckets. And then for the bucket resolutions, I'm not going to touch it. I'm going to leave them like they are. Here, I'm not going to touch the text encoder learning rate or the T5XXL learning rate. One thing that is important though, the unit learning rate should be the same as the value that we selected for the learning rate up here. So make sure that you have that. The default is correct, so I'm going to leave it as it is. Here, I'm going to select the no-half VA. It works fine with the 5090 with this, so I would say if you have a 5000 series, you can probably select this and not have to worry about it. And here, this is a very important section here, the network rank dimension and the network alpha. This is how you define how true to the character you want the training to be. So this is very important also because this depends also on the amount of VRAM that you have available. The higher the number that you put here on the network rank, the more the result is going to look like what you want. So especially for a human character, a realistic character, this should be as high as you can, honestly. Well, not all the way up, because it can go all the way to 512. But for example, in my case, I use 128 because I have plenty of VRAM and I want my human characters to be very, very realistic, very close to the reality. So I would easily be able to get away with 128 because of the amount of VRAM that I have. But if you have less VRAM, you can start with something like 32, for example, or 64, and then see if it doesn't crash for you. If it crashes, it means that you're going over the VRAM that you have, and then you have to pick a lower number. So in my case, I'm gonna go with 128, and usually the network alpha is half of that. So I'm gonna go with 64 here, and it should never be higher than the network rank. That's a very important thing. It has to be anywhere from 1 to that number, but never more than that. And then that is basically it for the basic parameters. So I'm going to reduce this, and I'm gonna save it. Alright, I have saved my changes, and I'm gonna go into the advanced parameters here to make sure that everything makes sense too. So in here, the first thing that I want to make sure that I change is where it says keep n tokens. I want to make sure that this is 1. And why do I want to make sure that this is 1? Because this is telling me on each file of those, I want to make sure that I never remove POTUS 47, which is my trigger word. So it can clip, and like when it's doing the training, it's gonna be like focusing on different aspects of it. But in here, I'm telling it always make sure that you focus on my trigger word. So that's important here. I'm not gonna change anything else on this side here. And in here, I want to make sure that I check the memory efficient attention, the shuffle caption, and the gradient checkpointing. And in here, I want to make sure that I use Xformers because I have an NVIDIA card, so that should be no problem for me. Usually, AMD needs to use SDPA. And that is it for the advanced. I don't touch much else here, so I can reduce this here and save again. And now all my changes are saved. One last thing that I want to do is I want to go into samples here, and I want to say that I want to sample every 1 epoch. What does that mean? It means that every time that I complete the training for 1 epoch and I save the epoch file, I want to test that epoch file to see if I get something somewhat similar to what I'm expecting from the training. So when you do this, you have to put a prompt here that will tell the trainer to generate a sample image using that last epoch to see the results that I get from that. So you would have to follow this pattern here. Like it says, you have to put a positive prompt, and then you have to specify a size of the image, and you have to specify a seed, a config scale, a sampler, and a negative prompt. So let me fill this up really quickly, and then we're going to discuss it. So this is what my prompt is going to be like. The first part is the positive prompt. That means, what do I want to see in that image? So the first thing I'm saying is I want to see POTUS 47, which is my trigger word. And I am making sure that that's highlighted. The parentheses means focus on this. I really want this. So by putting 3 parentheses, I'm saying I definitely want to see POTUS 47 here. And then I'm saying I want to see a man wearing a black suit, and it's going to be him alone. I want to make sure that I get a perfect face, perfect eyes, perfect anatomy, perfect hands. I want it to be a masterpiece and photorealistic. So that's my positive prompt. And then for the negative prompt, I don't want a deformed face, deformed eyes, deformed limbs, extra arms, extra legs, extra fingers, something that looks morbid, or a deformed body. And I want that image to be 1024 by 1024 using 27 steps and 7 as the config scale. So that is my prompt to generate those sample images when the training is happening. So now I can say here that I'm going to use the Euler ancestral sampler, or I can pick another one. Let's say, yeah, Euler is fine. So I'm going to reduce this, save, make sure that I have all that saved. And now we have everything that we needed in our parameters. So now we're fully configured. We have the model selected, we have our folders set up, our data set is prepared, and we have our parameters ready. So now we should be able to, let me go back into the model here for a second. We should be able to then just hit the start training button, and then it should start our training session. As you can see here in the model folder, we get a configuration file. We get a JSON file here that has all the information related to this training session, and a sample folder. And in that sample folder, you'll see that we have a prompt, and that's the prompt that we said that we want it to use to generate the sample images. And if we see here, we have a bunch of buckets based on the different sizes of the images. Like I said, for example, on this specific resolution, 768 by 1152, we have 40 steps or 40 images that are going to be used for training at that size. And you see that there's a bunch of different sizes, and it has different numbers of steps that it's going to be running in that training. And as you can see, it's already started loading things. So we just have to give it a little bit of time. It's going to load the model. It's going to load the images. It's going to create a cache of the images. So you see caching latents right now. We have 50 images. So it's caching all those 50 images. If we go into the image folder, we'll see that it's creating MPZ files. You see, NPZ. Those are the cache latents. So we're good there. It's filling that up, and it's preparing our data set. And now it's saying that it's going to work with the Atom W optimizer, which is something we specified. And here gives us a summary of what it's going to do. It's going to train 1,000 steps. So that's the images multiplied by the repeats. And in here we have validation images. We have nothing. We don't have regularization images, so that's 0. And then how many batches are going to be per epoch? So we have 1,000. So how many epochs we want? 15. And then it says the total optimization steps is going to be 15,000 steps. Why? Because we have 1,000 steps per epoch, and we want 15 epochs. So it's going to be a total of 15,000 steps. And we can see here that that's the count that he has here, 15,000. And as you can see, this is increasing because it's doing the training image step by step. So this is going to take some time. In this case, because I'm using FP16, it says that it's going to be taking a long time. So I'm going to probably stop this and then redo this with a bigger set of in a batch. Because remember, this is taking long because it's going one image at a time. And this is why I said it depends on your VRAM. If you don't have a lot of VRAM, you're kind of screwed. You have to be patient. You have to go image by image, step by step, and then it's going to take a little longer to do the training, but it's going to work. Now, let me stop this and let me increase the batch size to see how that affects this. All right, the training has ended. I'm going to remove everything that I have here. I don't need it. And then I'm going to go here into the parameters, and I'm going to go into the basic, and I'm going to increase to 12 because I know I am able to handle 12 images in one go. So I'm going to save this now, and then I'm going to restart the training and see what kind of result we get out of that. So restart the training. It recreates everything here again. It doesn't need to do the latent caching because it already did it, and those NPC files are there. So it's going to be a little bit faster now. So let's wait for it to get ready and give us the summary of the steps that it's going to execute and all that, so we can kind of see the difference. So as you can see here now, it's saying again, we still want to train 1,000 images by repeats. But if you see, the batches per epoch dramatically got reduced. From 1,000 batches per epoch, it's now 92, because now I have 12 images in one go that I am training at the same time. So what happened here? Remember, we said we wanted 15 epochs, but now since we're training so fast, because we're using many images at the same time, we're not even going to get to the epoch 15. We're just going to get 14 epochs. So that's one of the results of having a bigger batch. And then it says that the total optimization steps is going to come down to 1,250, which is a lot less than 15,000 that we had before, because now we're grouping a bunch of images together when we are training each step. And now if we come down here, we'll see something very important here, is that we no longer have to wait 8 hours for the training to occur, because now we're training multiple images at the same time. So it brought it down immediately for like less than 2 hours in this case. And I'm still running on FP BF16. If I change that to BF16, it'll probably be a little faster. So for the sake of the video, I'm gonna let this continue, finish the training, and then we'll see the results of the LoRAs and the epochs for the LoRA that are created. So I'll be back when this has moved along a little bit. Probably we'll see a few samples here by then, and then we'll continue on the video. Oh, I am sorry, there is something very important that I wanted to show and I forgot before when I was doing the one step, but I'm not gonna stop it and start it again. So if you can see, I have 32 gigs of dedicated VRAM for my graphics card because I have the RTX 5090. Now, by using 12 images in a batch, I have increased the use of my VRAM in this training session to almost 27 gigs. So that's why you have to be very careful of what kind of settings you put in the parameters, because this is when you get crashes, when it tells you I don't have memory to allocate for the training. So the type of training that you're going to do, if it's going to be FP16 or BF16, that affects the VRAM a little bit. The size of the batches affects also the amount of VRAM that you use. The size of the image that you're using to train also affects. So if I were to train 512 by 512, it definitely will use less VRAM. And so those are things that you have to take into consideration, because those are going to be the restrictions that you have to put in place in your parameters and your configuration based on your hardware. If you have less RAM, you're going to have to reduce the network rank, you're going to have to reduce the alpha, you're going to have to reduce the batch, you're going to have to reduce things like that so that you can fit everything into the VRAM that is available to your graphics card. I hope this information, this little parenthesis, is very useful to you, because this is where a lot of people go crazy and they don't understand why they can't train or what's going wrong. And these are the things you have to look for to optimize your training to the hardware that you have. Alright, we have completed the first epoch. So the epochs are every 92 steps and we're already on 100. So as we can see here, it created a sample image for us based on that specific tensor file that was created for that specific epoch. If you see, we have POTUS 47 SDXL, but we have a number 000001 because that's the first epoch that was created. So we're using that epoch, it created this image. And if we open this image, we can kind of start to see if it matches or not something that we want. So in this case, yeah, it doesn't have the high resolution fix, so it's not a perfect image, but we can see the outline of what would be the result of this image. For the first epoch, it's actually not bad at all. We can see clearly the silhouette of Mr. Trump, and we can see the hair, which is a signature of his. We can see that he is in the White House. We can see the flag. We can see all of that stuff here that is very similar to what we use to train the model. And he is wearing a blue suit, which he usually does, with a red tie. So everything is telling me that this LoRA is coming out nice. Obviously, it's not going to look perfect on the sample images, but it gives us an idea of what we can expect to get when we use these LoRAs. So let's let it continue, let it work, and then we'll continue monitoring what we get on the sample images and stuff. And then we're going to do a test run using this LoRA to see what we can get using automatic 11 and 11 with the LoRA files that we generate. Alright, 15 minutes have passed in this training session and we have our second epoch ready. As you can see, a sample image was generated, and this is something that I want to highlight. If we see the first image here, we see the silhouette and everything looks very similar, but remember in my prompt I said that I wanted a black suit, and it just gave me a blue suit. Now if we go into the next image, now we see that it's kind of adjusting better. We can see the facial details a little bit better, and it is actually giving me a black suit. So it is following my prompt a lot better. So that's really good. That's telling me that the training is going well. So we'll let it continue and we'll be back when we see the third image. Alright, we have gotten to the point where it's generating the third image, and as you can see, It has generated the image live when we're recording here, and let's see how that looks when it compares to the other ones. So this one looks like was black and white kind of that it tried to generate, and as we can see, this Epoch is looking a little bit better on the face. Like some of the details are looking better, but the hands are a mess right now. So definitely compared to, well, all the hands have been messed up so far. This one has a bunch of fingers. This one has less fingers than it should. Looks like ET or something. And then this one is I don't know, fat fingers or something. But we see that the details of the face and stuff like that is getting better. The shield is making more sense in the background, and the eagle in the flag is also looking better. And the training session has completed, and I was using my computer, so I was kind of compromising a little bit the resources, and it took about almost 2 hours to do the full training. If we come down here, we can see all the sample images that were generated. So the last we saw, I believe, was this one. And if we review the other images, we can see that the training was pretty good. I mean, there's a lot of details that were captured here, and even without the high resolution fix and everything, it looks pretty decent. Looks pretty close to the real thing in a lot of the cases. So we can now proceed and then try to test this out using the automatic 11 to see which of these epochs we think is the best one to use, and then use that as our LoRA. So what I'm gonna do is, the first thing, I'm gonna go back into the models, and here I have all the tensor files that were created. So it's 13, and the last one doesn't have a number, so because we ended up with 14 epochs. So we're gonna get these files, I'm gonna copy those, and then I'm gonna put them where I store all of my LoRAs for the automatic 11 application. So within my automatic 11 where the models exist, there's a LoRA folder. Inside that LoRA folder, I created another folder called POTUS 47, which is my trigger word, and SDXL, which is the model that I used. And in there I have all my tensor files. So now I have them available in the directory where my automatic 11 is going to be able to see them. I am now going to exit Kohya so I don't have this consuming resources, and then I'll just start my automatic 11 application, and then we'll be testing using that. Alright, my automatic 11 has loaded, and I have selected a Stable Diffusion Extra Large base as the model that I'm going to be using to generate the images. And in here I can see in the LoRA section that I have all my LoRAs here. I have refreshed to make sure that I can see them. So we do have that. So what I'm going to do here is I'm going to select the one that doesn't have a name so that it shows up in here as a LoRA that is selected. And I'm going to go back into the generation here. I am saying that I want to see POTUS 47, which is my trigger word, and I'm specifying to use a LoRA. And I have some negatives here to make sure that I don't get things that I don't want, like extra hands, missing hands, and stuff like that. And I'm going to be using the DPM 2 million SDE as the sampling method. I'm going to use Keras as the scheduler type. And I'm going to activate the high resolution fix because I want to make sure that I get a decent size image. So we're going to change this. I'm going to use 960 by 540 so I can get a full HD image generated, like if it was a picture from a TV screen. And when it comes to the config scale, I'm going to leave it as 7, which is usually the default. I'm going to increase the steps here to 27, and that looks pretty good to me. Now we need to test all the LoRAs, so in order to do that, what I'm going to do is I'm going to go here in the scripts, and I'm going to select the XYZ plot, and in here we're going to say we want a horizontal strip of a test of all the different LoRAs. So I'm going to say that I want to change the prompt SR, and what I'm going to change from the prompt is this part here. I want to be able to generate by changing this. So I'm going to put this here, and then I have to put the numbers of the different LoRAs that I have. So if we go here, we have from 1 to 13. So we should be able to do this, and it's 4 zeros leading for 13, and for 1 is 5 zeros. Okay, so that's good to know. Let's go here and then add those values. So this will be 1, 2, 3, 4, 5 zeros and 1. And what I'm going to do is I'm going to copy this multiple times: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And now we adjust values here. So 2, 3, 4, 5, 6, 7, 8, 9. And then we need to make the space correct here. So get rid of one of the leading zeros and then replace that with the proper values. So what is this doing? It's going to replace this section of the prompt, generate an image, replace it with the next one, and so on until we get a strip that has all of the LoRAs tested. So everything is looking good. I don't want to do anything else here. Now we can just tell it generate the images, and then we'll see the results of that in our outputs folder. So let's go here and wait for it. It has started generating the images. We can see here what it's creating. We should see a new folder come up here with today's date, and then we'll see those files being dropped in there. All right, the folder was created, and here's our first image. So let's let it continue. It's gonna take a little bit of time. It's probably about like a couple of minutes to do all of this. So let's be patient and let's come back after it's done to see the results. All right, we're almost done. We're generating the last image here, and it should also create a grid image for us so that we can compare the results of the different epochs of the LoRAs. So once that is done, we'll open that and kind of see what we get from here. But this prompt was actually very simple. We just wanted to make sure that it was actually capable of showing us Donald Trump in an image. So that's very straightforward. So it's going to be all over the place. We're going to see a bunch of different weird things, but the important thing that we want to see is if Donald Trump shows up in those images. So now we're at the point where we're generating the grid. So let's give it a little bit of time. Here we go. Now we have our grid. Let's open the PNG one, which is high resolution and pretty big. So then we can see here. Let's go to the first here. So this is the final epoch of the LoRA. So we can see that we do have Mr. Trump here in front of an airplane, but there's something wrong here with the face. Something doesn't look quite right. And then we go from the very beginning. So the first epoch, as we can see here, looks like it wasn't trained enough because we don't even see Mr. Trump here. So that kind of lets us know we should start looking forward. So we look at number 2. It's looking a little better. The face a little better than the other one. But here we can see better faces, right? From Epoch 3, now the face is kind of making more sense. Epoch 4, Epoch 5, not bad. Epoch 6, 7. So yeah, I mean, we can see that definitely it is giving us Mr. Trump. Now we just kind of have to identify which one of these would be the best one to use when we're generating images. So for that, let's create a different prompt that is more useful. So what I'm going to do is I'm going to modify this, and I'm going to say something like, so this is what I want now. I want a green background, like a green screen type of photo. I want a portrait of a man. I want it to be photorealistic, hyper-realistic. I want it to be a masterpiece where the eyes are perfect, the hands are perfect, and the mouth is perfect. So this should get me a better image where I have only POTUS 47 in there, and we'll see how that works out. So let's trigger a build with this. Let me get rid of this and see what the results are. Alright, it has finished creating the images that I requested, and here we can see something interesting. That's one of the tests that I like to do. I like to make sure that I remove all the noise and I focus only on the character. So in this case, we're generating like a green screen kind of background where we only focus on the character of Trump. And if we can see here, this is the final epoch, which has kind of a lot of details, but if you notice there's a lot of imperfections on some areas like the eyes, but in general it's pretty detailed. You can see the hair, like, you know, single strands. You can see most of the features and all that, so that's good. Let's go back here and compare the previous one. So that's the first one. Definitely looks messed up compared to the other one, and you can see as it increases and gets a little better with the training. So here we're in epoch number 4, and this is looking a lot better now. So we can start saying that maybe from epoch 4 or 5, that's when we start getting decent results. So let's continue seeing here. All right, epoch number 6 definitely looks very good. There's still some lip weirdness and some weirdness here, but overall it's pretty good. Epoch number 7 definitely looks a lot better. 8, I would say this is a good candidate. This is a good candidate to use. Let's continue here. 9, definitely good too. 10 is also very, very good. We can see all the details. We can see the eyebrows and everything is really good. So 11, 12, yeah, definitely at this point. 13 is probably the best one of them all so far. So now we can get an idea of which epochs we kind of think are possible candidates. So I would say right now 13 is a candidate, 11 is a candidate, 8 is definitely a candidate. Like I would say those are the top 3 as of now. But I want to see how flexible it is when it works with the LoRA. So I want to do another test, and in this other test I'm going to try to change things that normally you wouldn't see in his pictures. So first of all, let me say that I want the LoRA to be facing the viewer, and I want to make other changes. So instead of a green background, we're going to say that he's wearing a Hawaiian shirt, and he's also going to be wearing shorts. I think I misspelled this. Hawaiian, okay. And let's say that he's on a beach. So now we remove the portrait because it's not going to be a portrait. And he's going to be on a beach wearing shorts and a Hawaiian shirt, and he's going to be facing the viewer. So let's see what the results that we get from this are. I also noticed that the Euler Ancestral kind of gives better results, so I switched to the Euler Ancestral. So let's see what we get from this. We're going to see the flexibility, if we can actually get the LoRA and make changes to its appearance and its the situation in which we put it. Alright, it has generated the images. Let's look at them really quickly. And we can see here the last epoch definitely has a lot of details, but I would say definitely it seems like it's overtrained because, for example, we don't see any Hawaiian shirt. We see defects starting to crop up. So even though we get a lot of very fine details, I think it's too much. So I would probably not use this one. Now, if we look at the first 3 epochs, definitely the training was not enough because it cannot focus on POTOS 47. As we can see here, it just focused on the pants. So definitely we're not going to be using any of that. When we can see good, decent results that are usable is starting on epoch number 4, but still we see that it's kind of missing details. So I would probably skip this one and start looking seriously at 5. 5 looks pretty good. We have a lot of details. We can see that it focused on the prompt, so he has the Hawaiian kind of shirt and the shorts. He's on a beach, and that's definitely POTOS 47. So this is looking good. And then in here, we have a little bit of distortions here with this weird bullet kind of blob and the hand hanging around. But this could be attributed to the fact that I'm using the base SDXL model, and they tend to be hard to give you like really, really nice crisp results. But this image is actually pretty nice in general. So I would still consider this as a possibility. Number 7 is definitely nice. You know, with the glasses, you can still see under the glasses. You have the nice reflection, a lot of nice details. You can still see a lot of the details regarding the POTOS 47 character. Number 8, for some reason on this image, got lost in the focus. It focused on other stuff. So this is kind of disappointing here. 9 is looking better though. 9 is looking definitely nice. 10 is looking okay, but you see distortion on the face here. I don't know why that happened. And 11 also. And yeah, it looks like when you get to 13, then you start definitely seeing the overtraining that causes defects. Alright, so yes, that's what you get using the base Stable Diffusion Extra Large model. One thing that I would highlight here is that if you plan to get images that are very detailed, very fine-tuned, you probably should not use the extra large base model for that. So if that's your goal, then you should probably train your LoRA on another model that is more detailed. For example, if you go into Civet AI, you'll find a lot of good, very realistic models by Stable Yogi. So you have those that he puts out there. There's also Juggernaut and a bunch of other ones that are really good, that get you really high quality images. And if you train your LoRA on those, then you're definitely gonna get like really high quality, very detailed, very few imperfection, results with that. But you also have the opportunity of doing your training with a base model that is kind of common for all of the different models, and then you can use that in all the other fine-tuned models to kind of get different results. So up to you, it depends on what you really want. So I would definitely suggest both approaches for you to try. And yeah, Yogi has very good models. He has a Patreon and he creates even more detailed and bigger models that you can get if you support him. So I would recommend check his Patreon out because he puts out good stuff out there, and it's constantly that he does that. So hopefully this was good enough for you to start training your LoRas, to start getting an idea of how to figure out which epoch to choose to use later, and kind of give you a little bit of strategies on how to do the picking of that and doing your training in a way that is very useful and successful for you. So I'm going to leave it here. That's going to be it for this video. It was a little bit long. I'm sorry, but I want to cover a lot of things that I think are important in a crash course. So if you like it, hit the like button, subscribe to the channel if you have not done so. That really helps us, makes us grow, makes us get more exposure, and hopefully we get opportunities to monetize the channel later without having to bombard people with ads. And talking about that, you should have not received an ad. That is on purpose because I'm not currently monetizing the channel. I'm relying entirely on the support of my viewers and donors. If you want to support me in this effort, there's a link in the description below to PayPal where you can donate directly. I always shout out the donors on the beginning of the next video. And there's also a Bitcoin address if you would prefer to donate that way. So you have those two options. And yeah, that's going to be it for this one. I'll see you in the next one.